So demystifying software architecture. A journey begins. A journey begins. So it's gonna be interesting, I think. Maybe. But there's only one way to find out. This is the next. Oh, this is not even a comment. We're the first people, maybe, to read this. Although it was posted a day ago, so it must have been buried. Either that, or it was really, really bad. Picture a skyscraper, a majestic symphony, or a well-organized city. What do they all have in common? There's buildings, there's construction, there's cement. They are the result of a meticulous planning, structure, and a strong foundation. Similarly, software applications are no different. Behind every successful software system, there's a hidden hero, a software architecture. Does your boss value software architectures? It's very likely that not. But when it comes to building a foundation, a base, an organized structure in a program, it's usually not given priority. It's not even a thought. Just get that feature done and you'll be paid. So understanding the blueprint. Software architecture is the blueprint of your digital realm. And it sucks when you don't have a blueprint, doesn't it? It's the grand design, the master plan, and the map that guides developers through the intricacies of creating powerful and robust applications. But what exactly is software architecture? At its core, software architecture defines the structure of a software system, specifying its components, their relationships, and the overall organization. It's the process of making high-level decisions about the software structure, ensuring that it meets the desired quality attributes, including performance, scalability, maintainability, and security. Sounds foreign to you? I bet. Not every software developer gets the luxury of working in an application that has a well-defined structure. Even I build good foundations for personal projects that I don't really consider them to be super duper serious. I can give you an example for an extension that I built. I organized it based on hookers. So you've got a hooker that is responsible for hooking into one part of the system of a website, and then that hooker alone is the only one that can control that part of the system. And therefore, the extension is only able to extend the website through that hooker. And it does that by asking the pimp about it. So there's a pimp, and all the hookers belong to the pimp. And if you need a hooker, you got to ask the pimp about it. And it's super easy to reason about it. But there's a good example. The pillars of software architecture. Let's break down the key elements of software architecture. Components. Software architecture identifies the primary components that make up your system. These can include modules, libraries, databases, and external services. Each component has its role and responsibilities within the system. Connections. It outlines how these components interact with one another. This includes defining communication protocols, data flows, and dependencies. Understanding these connections is essential for ensuring that the system functions smoothly. Mind you, spaghetti is not a connection. Quality attributes. Software architecture defines the quality attributes the system should exhibit. These attributes may include performance, reliability, security, and scalability. The architecture serves as a roadmap for achieving these goals. Patterns and styles. Architects often apply architectural patterns and styles to solve common design problems. These patterns provide proven solutions for recurring issues, saving time and ensuring best practices. These are some really good examples. It doesn't have to be just all these four. Depending on your needs and on what you're building, you might need to define more structures, more pillars. But then again, it's up to you, the architect, to make that decision based on your needs. The architect's role. Architects are the masterminds behind the architecture. They need to balance the technical aspects with business requirements and constraints. An architect should be a visionary, capable of seeing the big picture while also understanding the minute details. They must consider trade-offs, plan for future changes, and ensure the system aligns with the organization's goal while still making sure they do everything else, getting paid the same thing. Real-world examples. Software architecture isn't just theory. It's a vital part of our digital world. Web applications. Think of the architecture behind popular websites, ensuring they handle millions of users simultaneously, provide a seamless user experience, and protect sensitive data. Mobile apps. Mobile app architecture ensures that your favorite apps run smoothly on your smartphone, connecting to servers, managing data, and responding to your taps. Enterprise systems. Large organizations rely on software architecture to coordinate the diverse systems that keep their operations running efficiently. And embedded systems, even the smallest devices like smart thermostats have software architectures to manage their functions. They sort of lost me on this one, but Hong Kong, I guess. Like 2 web applications can do, and most likely do, very different things to the point where their architectures aren't even comparable. I'd say that this paragraph applies to web servers, not web applications, and mobile apps. I think this applies more to the operating system's API, not so much about the apps themselves. Yeah, completely lost me on that one. Yeah, more like a platform, not an architecture. Oh, subscribe to my newsletter. Stay in the loop, get new articles from 10x Engineer Journey delivered straight to your inbox. Well, damn it. I guess we cannot read the conclusion. Damn. What do the people have to say? Oh yes, that's right.